చాట్ జీపీటీని బామలుగా వాడట్లేగా. సడన్గా చాట్ జీపీటీ బంద్ అయిపోతే హలో, అరే వినిపిస్తుందా? హలో. యా. సో isomerism is good, right, everyone? నేను కనిపిస్తున్నానా? Today we'll discuss one of the important topic in organic chemistry. To understand total organic chemistry, so purely depends on the reaction mechanism. Why reaction takes place? How many types of reactions are there? Why the reaction? Which type of reaction is there? For example, alkenes undergoes which type of reactions? Alkenes undergoes which type of reactions? Alkynes undergoes which type of reactions? All these reactions, because alkyl halides, alcohols, aldehydes and ketones, total organic reactions. So a lot of students, 90, 95, 99%, sometimes 99 students, 99% of students, so will generally mug up the reactions. They don't know why the reaction happens. What is electrophile? What is nucleophile? What is electron deficient species? What is electron excess? What is more electronegative? What is less electronegative? Which is more crowded? Which is more steric endurance? Less steric endurance? Right? Which solvent? Polar solvent or non-polar solvent? Polar protic solvent or polar aprotic solvent? A lot of solvents are there. So living groups are there. A lot of living groups. So means which is best living group? A lot of things are there. So we will discuss particularly in that particular case. Okay. So one of the important types of reactions, total. For example, imagine in India, how many types of people we can observe. So in India, for example, how many types of people we can see? How many types of people? Broadly, if we if you are broadly if you are classifying. So for example, in gender basis, right? Male, female, trans. I mean third. Mainly, if you go throughout the India, so wherever you go, you can find that one. But once again, further classifying takes place, right? So if we go with the religion, how many types of people we can see? Religion: Hindu, Muslim, Christian, Jain, Sikh, Buddhism, some more. Only 4 or 5 types. But if you go any state, so you can find any of that one. But a lot of people, what they are doing, they are going to the city and they are keep on asking, oh, which type of religion you are. They are writing Hindu, Buddhism. So like that, so the people are confusing that. But if we know which type of reaction, right? So first, before going to the type reaction mechanism, so already I told you electrophile, right? Electrophile. What is electrophile? Electron. So whenever if you are forgot this electrophile, philic nature, philic opposite word is phobic. Philic means attracting. So electrophile means electrons attracting species. Which species will attract the electrons? Electron deficient species. Electrophiles are nothing but electron deficient species or electron, right, taking species, right? So electrophiles are 2 types: charged electrophiles, neutral electrophiles. Charged means what? Right? For example, CH3 plus, Cl plus, Br plus, I plus, like that. Neutral electrophiles. For example, BF3, BCl3, AlCl3, FeCl3, etc. So charged means we can see the charge. Charged electrophiles. Neutral electrophile means there is no charge, but they act as a electrophile, like SO3. CO2. These are all neutral electrophiles. So electron deficient species. For example, K plus, electrophile are charged electrophile or neutral? Hello? K plus, Na plus, charged electrophiles or neutral electrophiles? Charged, right? But these two, like these are not electrophiles. Na plus and K plus, right? Alkali metals. Sodium is in the positive state, it's more stable. Why? Sodium 11, right? 2, 8, 1 this is. Na plus, if it is losing one electron, 2, 8 only, means neon electronic configuration. Na plus is more stable than the Na. So it's not deficient by default, right? I don't want this electron. If this electron goes out, so I'll be more stable like that, the Na plus will fill. So like alkali metals, even though they are having the positive charge, they are not electrophiles. Okay, clear? So a lot of people are confusing this type of questions they are asking. So we'll say electrophile means charged and neutral. Charged means positive charged, neutral means this is neutral. But so they are asking this type of questions will in the fall. Okay, first we need to know the electrophile. So then what about nucleophiles? Nucleophile. Nucleophile. Nana. What is nucleophile? So nucleus attracting. Nucleus means which charge? Positive charge. Means simply opposite to electrophiles. Electron excess species. Electron hating species. Those are electrophiles are electron loving species. These are electron hating species. So here also nucleophiles are also two types, Nana. What are those? Right? Charged electrophile, charged and neutral. Charged means what? For example, Cl minus, Br minus, I minus, OH minus, Cn minus, like that. So neutral electrophiles. Neutral ones, water, H2O, NH3, etc. Oh, water nucleophile. So H2O is acts as a nucleophile, right? Hello? Oh, no, H2O to not H2O only. Oxygen as having the two lone pairs. Nucleophiles. So electrophiles, nucleophile, and we need to know one more is free radical. Free radical. What is free radicals? When bond is undergoing homolytic cleavage, like radicals, like Cl radical, Br radical, I radical, CH3 radical. So I radicals generally won't form. So CH3 radical, etc. Okay. So right now I just spoke about three: electrophile, nucleophile, free radicals. You are clear, right? Electrophile means electron deficient species. Nucleophile means electron excess species. Free radical means free radicals. Okay, done? Hello. Now, addition reactions and substitution reactions and elimination reaction. So first, addition reactions. What are addition? Addition and substitution. What is the main difference? Right. So it is imagine this is a molecule, right? Okay. Imagine I'm just this yellow color one. Can you see that yellow color one, right? I'm just adding this. This is we are called as which reaction? Addition. So simple something if you are adding that reaction we are called as addition reaction, right? For example, one more reaction. This is blue color, right? Blue only. Purple or blue? Purple, for example, whatever it may be. So if I am purple one replacing with this yellow, This reaction we are called as substitution. Substitution. So there is first addition, substitution. Next is already one molecule. I am just eliminating this. This reaction we are called as elimination reaction. So right now, three reactions, right? Addition, substitution, elimination. For example, this position, if I am changing this yellow position, I am changing to blue position. Blue position is coming to yellow position, right? This reaction we are called as rearrangement. Rearrangement. We are not adding, we are not substituting, we are not eliminating, we are just rearranging. So this rearranging we are called as rearrangement reactions. Got it, everyone? Hello. So right now I discussed, right, addition reactions. Addition means simply adding. For example, try to understand. In this case, purple color ball I am adding to this one, right? Imagine this is a purple color ball adding to this one. So purple addition reaction. Or yellow color if I am adding, yellow addition reaction. Yes or no? If I am adding the pen addition reaction, right? If I am adding the remote addition reaction. Right now, if I am adding a electrophile, but if I am adding a electrophile, which reaction that is? Electrophilic addition reaction. So addition reactions, once again we are going to classify three types. Electrophilic addition reaction, write it down. So then next one is, if I am adding the nucleophile, nucleophilic addition reaction. If I am adding the free radical addition reaction. Addition, electrophile if I am adding, those reactions were called as electrophilic addition reaction, write it down. If I am adding the nucleophile, nucleophilic addition reaction. So in addition reactions, one of the important thing is there is no byproducts. What is byproducts? Substituting, when the substitution takes place, so the byproduct is forming. But in this case, addition reaction, nothing is going out. We are just adding. Electrophilic addition, nucleophilic addition, free radical addition reactions. So electrophilic addition, basically, generally alkenes as well as alkynes undergoes electrophilic addition reactions. Nucleophilic addition reactions undergoes aldehydes and ketones. But some carboxylic acids and esters also undergoing, but majorly what I am speaking. And free radical addition reaction, alkenes in presence of peroxide, not only H2O2, peroxide, benzyl peroxide also will use. Alkenes in presence of peroxide. So these, whenever the aldehydes, ketones I am speaking, aldehydes, ketones combinedly we are called as what, Nana? Right, carbonyl compounds. Carbonyl compounds. Carbonyl compounds. So in the 11th class, for the 11th class, electrophilic addition, free radical addition is important. For nucleophilic addition, for second years. Done? Timing aitunda? నేను చూస్తాలే. అవుతుంది. నెక్స్ట్ నాన్న substitution reactions. Substitution reactions. Substitution reactions, once again we are going to classify three types: electrophilic substitution reaction, nucleophilic substitution reaction, free radical substitution reaction. Free radical substitution reaction. Electrophilic substitution generally takes place on benzene ring, on benzene ring, benzene, and substituted benzene also electrophilic substitution reaction takes place. Nucleophilic substitution generally takes place in presence of alkyl halides, majorly alkyl halides or haloalkanes, somewhat alcohols and ethers, like that. Majorly alkyl halides. Free radical substitution takes place in, right, alkanes. So for the first year we need to understand free radical substitution, electrophilic substitution, electrophilic addition, free radical addition, right? So nucleophilic substitution, once again we are going to classify two types, three types. SN1, SN2, SNI. SN1, SN2, SNI. What is SN1? What is SN1? Unimolecular nucleophilic substitution. Unimolecular nucleophilic substitution reaction. This is bimolecular nucleophilic substitution reaction, right? This is intramolecular nucleophilic substitution reaction. Intramolecular nucleophilic substitution reaction. SN1, SN2. This is a very important for the second year, guys. So addition reaction, substitution. Now let's go faster. Done or no? Completed? Next one, elimination reactions. Elimination, just removing. Elimination reactions, once again we are going to classify how many types? Two types. One is alpha elimination, beta elimination. Alpha elimination, beta elimination. This beta elimination, once again we are undergoing three types, right? What was the E1, E2, E1CB? Elimination reactions are two types: alpha elimination, beta elimination. What exactly the main difference between alpha elimination and beta elimination? Hello. For example, from HX is here. Imagine if you want to remove, right, these two H and this is X from the same carbon, right? Same carbon, same carbon were called as alpha elimination. If the same, if you are removing from the adjacent, Nana, what exactly adjacent? It is H and here is the X. From adjacent we are called as beta elimination. Beta elimination. Beta elimination. Write it down. Alpha elimination and beta elimination. Hello. Okay. నేను క్లాస్లో ఉన్నాను మళ్ళీ కాల్ బ్యాక్ చేస్తాను. What is the main difference from alpha elimination, beta elimination? What is alpha elimination? What is beta elimination? Alpha elimination means from, if you are remember, two atoms or ions, whatever it may be, from the same carbon, we are called as alpha elimination. From adjacent, right, this carbon, two carbons are here, right? So here from X and here from hydrogen, that is called beta elimination. Beta elimination, once again, we are called as unimolecular, bimolecular, intramolecular, right? Intra means not intra, conjugate base. So those things I'll discuss. Right now, how many reactions we discussed? Right, addition reactions, electrophilic addition, nucleophilic addition, free radical addition. So alkenes and alkynes, aldehydes and ketones, right? Then next, substitution reactions, electrophilic substitution, nucleophilic substitution, free radical substitution. Once again, nucleophilic substitution, SN1, SN2, SNI. And elimination reactions, alpha elimination, beta elimination. Beta elimination, once again we are going to classify E1, E2, E1CB. Right? Next reactions, Nana. Next, rearrangement reactions. Next, rearrangement reactions. Some pericyclic reactions. Pericyclic reactions. Addition, substitution, elimination, those three are very important. Of course, rearrangement, some cases important. So first put the heading. Electrophilic addition reactions. Electrophilic addition reactions. Electrophilic addition reactions. Who are initiating the reaction we are called as, hello, who are initiating? For example, JN chemistry was initiated by JN, Jamuna Gesh. If someone is coming to join in my JN chemistry to explain somewhat physics or physical chem, whatever it may be, inorganic chemistry, organic. So will I change the name, institute name? If three members are joining, who are initiated, we will give you the name. So here the same thing, alkenes, Nana. Generally, alkenes undergoes electrophilic addition reactions, right? So actually they are the reactants. What exactly the product? Right, for example, HCH2Br. Here the mechanism is important, right? First, HBr undergoes H++ Br minus. right? HBr undergoes H plus plus Br minus. H plus were called as electrophile. Br minus were called as nucleophile. You may get one doubt, sir. Why HBr undergoing H plus as Br minus? Why not? For example, why not H minus Br plus? H minus Br plus. Why not H minus Br plus? Why? Anyone? Huh? It won't happen. Why? Br is more electronegative. Wait, very good. Right? Hydrogen and Br are sharing the electrons. Br is what? More electronegative. What is electronegativity? The tendency to pull the electrons towards itself. Right? The tendency to pull the electrons towards itself automatically. So H plus and Br minus. Don't confuse. Sir, why is H plus is electrophile? Why not Br minus? Means Br minus is more electronegative. That's the reason Br minus is like that. Clear, everyone? Right now. So now you may get confused here. Sir, in the product, electrophile, nucleophile, both we are added. But why we are saying that electrophilic addition? Why not nucleophilic addition? Yes or no? So first, Nana, first electrophile is coming and attacking. And before this going to this one, alkenes are two types. Symmetrical and unsymmetrical alkenes. Right? Symmetrical means what? Both sides. This is a symmetrical alkene. CH2 double bond CH2. If you can cut equally, so equal two halves will get, right? Unsymmetrical means what? This is, for example, both sides are same. This is also symmetrical. CH3 CH double bond CH CH3 symmetrical. Unsymmetrical means what? Unsymmetrical. For example, double bond, this is like this. If you can cut like this, this is one carbon, this is two carbon. So now this is a symmetrical alkene, no issues, of course it's easy. So now symmetrical case, H plus is coming and attacking now. Is attacking, it can attack first position, it can attack second position. So both are possible because it's symmetrical, right? For example, according to the product, so I'll go and attack the here. So H plus is having how many electrons? Ritvik, H plus is having how many electrons? H plus is having how many electrons? No, actually H is having the one electron. That electron is taken by the Br. Right now the H plus doesn't have any electrons. For the formation of a bond, right, we need two electrons, but H plus doesn't have any electrons. What exactly happens? Right. So, and before this, we need to understand one more important point, that is the basic fundamental. So when we are breaking the bond is two types, right? We are breaking the bond is two types: homolytic cleavage, heterolytic cleavage. So particularly, what is homolytic cleavage? Homolytic cleavage means C radical, C radical. For example, heterolytic cleavage means like this: one is C plus, one is C minus. So one is losing the electron. The two electrons are taken by that carbon. Heterolytic cleavage. Yes or no? Hello. For example, it is having the double bond. For example, one is having the double bond. For example, H plus is coming here. So try to understand one of this green color bond is coming this side. What exactly happens? Hello. See, here is yellow color bond is coming, right? H, here is the positive side. Electrolyte cleavage, we made it into this side. So now in this case, what exactly happens? This pi bond, which pi bond? This white color pi bond is migrating to this side. Here is the H plus is coming. What exactly product we will get? CH2, H and CH2, positive charge. Okay? Hello. So then the next step, what exactly happens, Nana? Br minus is coming and attaching over here. CH2H, CH2Br. So in this first reaction, first nucleophile, electrophile is initiating. So that's the reason we can call it as electrophilic addition reaction. So write it down. Write it down. Any doubts you can ask me right now. You may ask one more doubt. What is that doubt? What is that doubt? Sir, why only electrophile is initiating? Why not nucleophile? Yes or no? So first write it down, I'll explain that. Technically strong. JEE mains exam 2026 January. 4 lakhs 399 ఉండే వాళ్ళ దాంట్లో 4 lakhs వాళ్ళ దాంట్లో హైయెస్ట్ ఉన్నది నాదే ఎడ్యుకేషన్. హంసిని, so why only electrophile is initiating, why not nucleophile? For example, if yes, so for example, if the for example, if Br minus is coming and attacking like this, right? If it is attacking over here, so the bond is breaking like this, right? CH2 minus CH2 Br, but this reaction won't take place. Why? So means what I'm trying to say, alkenes undergoes electrophilic addition reaction but not nucleophilic addition. Why? Alkenes undergoes electrophilic addition reactions but not nucleophilic addition. Why? So, so same like charges, what happens? Like charges repel. Alkene means we need to understand, right? Alkene means because of side by side overlapping, right? Above and below the ear, negative charge is there, right? In alkene, above and below the double bond. For example, imagine this is a double bond, right? Above below the double bond, the electron density is there, sidewise overlapping. So negative charge and Br minus is also negative charge, right? So write it down because of repulsions between Br minus and alkene. So if someone asking you the question, why alkene undergo electrophilic addition reactions but not nucleophilic addition, means because we need to say, sir, Br minus is having the negative charge, even alkenes also are having the, so above and below the negative charge, like charges, what exactly happens? Electron repulsions are there, because here is Br minus is also free, but Br minus can't attack the alkene first. This is called as mechanism, in-depth mechanism. Why alkenes undergoing the electrophilic addition? Why not nucleophilic addition? So this is called as mechanism. Once we can understand, if someone asking you, right, alkene undergoing which type of reactions, means simply we can say electrophilic addition. Immediately they'll ask, why can't nucleophilic addition, right? If the nucleophilic addition takes place, what exactly happens? Repulsions are there between alkene as well as the reagent nucleophile. Simple. So free radical addition is possible. Free radical addition is possible. I'll discuss that. Clear, everyone? Done, Anna? Akshita, are you listening? Akshita, समझ में आ रहा है ना? कुछ जो भी डाउट है आई तो पूछो. हाँ, ऋत्विक అర్థమవుతుందా? ऋत्विక్ ఉన్నావా? క్లియర్ ఉందిగా? ఏకనా నీకు అర్థమవుతున్నాయా? So now we'll discuss in unsymmetrical cases. So to solve this question, right, we need to know when bond is breaking, we are getting one intermediate. What is that intermediate? Carbocation. So carbocation, right, electron deficient species. So it's having the sp2 hybridization, right? sp2 hybridization. Now what I'm trying to say, carbocations basically, so in terms of inductive effect, 3 degrees greater than 2 degree than 1 degree. So first basically we need to know according to the inductive effect, even if it is having the resonance or hyperconjugation also, we can explain the carbocation. So always carbocation we need to see the stability, first resonance, then hyperconjugation, then inductive effect. So first we need to cross check whether the resonance is present, right? Whether the resonance is present, obviously that carbocation is more stable. So then afterwards we need to cross check whether it is having the hyperconjugation or not. If it is having the hyperconjugation, we need to cross check the how many number of alpha hydrogens. That is the second point. And third point, we need to understand obviously 3 degree, 2 degree, 1 degree. And one more important thing, carbocation is having natural tendency of rearrangement. Natural tendency of rearrangement, NTR. Write it down. Not senior, junior. Natural tendency of rearrangement. Organic NTR. Not cinema star NTR. So senior NTR also natural tendency of rearrangement. He was the hero from as a politician, and he is a CM. So he cross-checked which is more stable. CM is more stable or hero is more stable? Huh? So automatically he was substituted. Means rearrangement takes place. Hero to CM. natural tendency of rearrangement means where the carbocation is moving, right, naturally by itself. First, to solve this one, we need to understand this. Okay, carbocation rearrangements and all. So if you need more details about this, you can go and watch my videos. Chalo, done? Right. The same question. Copying. Here we'll get two types of products. No? One is major and one is minor, right? A lot of students are by hearting this is major and minor. So for example, if the bromine is attacking here, 2-bromo, propane, and one more is possible, 1-bromo, propane. 2-bromo, propane, 1-bromo, propane. So 90% of students by hearting this is major, 2-bromo propane is major, 1-bromo propane is minor, atla by heart chestar, right? So to avoid the by heart, so what we need to do? What we need to do? We need to understand the mechanism. I already told you. What exactly the mechanism? Hello. HBr undergoes H++, Br minus. I already told you. Now, obviously, alkene undergoes which type of reaction? Which type of reaction? Electrophilic addition reaction. So the first electrophile is coming and attacking over here. So electrophile, Nana, it has two options. It can attack over here. It can attack over here. Two options are there. Two options are there where it is attacking. Yeah. Yeah. So H plus can attack first position. H plus can attack second position. Right? Where it is attacking? Where it is attacking? If it is attacking the yellow position, what exactly happens? Here we will get the carbocation. If it is attacking this orange position, what exactly happens? CH3, CH, H, CH2 plus. Now this is which carbocation? 2 degree carbocation. This is 1 degree carbocation. 2 degree, 1 degree. So I already told you which degree carbocation is more stable. 2 degree. Right. So this is more stable. More stable means more number of Br minus can attack. Right, there are Br minus is waiting for the carbocation. So this is more stable, right? Stable means more number of, for example, we are at bus stand, 100 members are there. 2 buses is coming. One bus is 1 degree bus, one more bus is 2 degree bus. 1 degree bus is coming and immediately going, just is stopping at the stop for 1 second. But 2 degree bus came for, it stopped for 15 to 20 seconds. So now in which bus more, right, people can climb? 2 degree, which is more stable. So there more number of Br minus will coming and attacking, right? CH3, CH, Br, CH3 and CH3, CH2, CH2, Br. So 2 bromopropane, 1 bromopropane. 2 bromopropane, 1 bromo. This is major. This is minor. Major and minor. Come on, write it down. Don't by heart. It's purely depends on the carbocation stability. Right? The 2 degree is more stable because 2 plus I groups are donating. It is right, only 1 plus I group is there. Write it down. Then, any doubt? So this only we could say Markovnikov's rule. Markovnikov's rule. So I'll explain that Markovnikov's rule, but Markovnikov's before that we need to know the mechanism. Purely depends on the stability of carbocation. What exactly the Markovnikov's rule? When an unsymmetrical alkene, this is unsymmetrical alkene. Symmetrical cases, Markovnikov rule is not valid. Unsymmetrical alkene. When an unsymmetrical alkene is added by the unsymmetrical reagent, the negative part of the reagent always attacks the double bond carbon which is having less number of hydrogens. The negative part of the reagent is always attacks the double bond carbon which is having the less number of hydrogens. That is called as Markovnikov's rule. What is anti-Markovnik means opposite, but not here. It's coming in the free radical addition reactions. I'll explain that. Yeah. So first write it down this. I'll explain that. Write it down. What is Markovnikov's rule? Write it down. Markovnikov's rule. Markovnikov's rule. Markovnikov's rule. So write it down. Markovnikov's rule. When an unsymmetrical alkene, when an unsymmetrical alkene, an unsymmetrical alkene is added to the unsymmetrical reagent. Unsymmetrical reagent. What is unsymmetrical means? H plus pen Br minus unsymmetrically we are dividing. Unsymmetrical reagent. So two ways we can say, but here is the negative part of the reagent. Write it down. The negative part of the reagent. The negative part of the reagent. The negative part of the reagent always adds double bond carbon which is having less number of hydrogens. Less number of hydrogens. Okay. less number of hydrogens. Or we can say like this also. The H plus will attack the alkene where the more number, double bond carbon which is having more number of hydrogens. Write it down, that also. Or H plus attacks the double bond carbon. H plus attacks the double bond carbon. H plus attacks the double bond carbon. Double bond carbon which is having more number of hydrogens. More number of hydrogens. More number of hydrogens. More number of hydrogens. Okay, that is called as Markovnikov's rule. Next, here onwards, the story will start. Now, write the questions. Try to write the products. Right or wrong doesn't matter. Same mechanism. H plus plus Br minus H plus attacks are there. So consider all carbocation stabilities and all. Yeah, possible, write it down. Otherwise, you can write the major also. Doesn't matter. Come on, write these 9 products. So here 7th and 8th cases important. Hello. 7th and 8th cases, the star mark, ring expansion takes place. Ring, which options? Ring expansion. Ring expansion takes place. For example, we are at auto. So we have the option of alto. So we'll go to the alto, right? Alto, and we have the desire. We'll go to the desire. Desire, and we have the option Fortuner. We'll go to the Fortuner. Expansion takes place because if we are ring is somewhat, because it's 6-membered ring, that is more stable. So right or wrong doesn't matter. So this 9 reactions, write it down, and remaining tomorrow I'll explain somewhat alkyne reactions and free radical addition, nucleophilic addition reactions I'll explain. Okay na? Right Nana? Shall I continue otherwise? Solid. ఇవి చేసుకోండి. దీస్ ఆర్ జస్ట్ ప్రాక్టీస్ అండ్ కమ్ బ్యాక్ టు టుమారో ఐల్ ఎక్స్ప్లెయిన్. ఎట్ ఏ టైం ఎక్కువ చేసినా కొంచెం కన్ఫ్యూజ్ అవుతుంది. రేపు చేద్దామా? రైట్ నాన్న.